Ton 618 should not exist. Roughly 10.4 billion light-years from the chair you are sitting in, there is a mouth in space. A literal region where matter falls inward forever and never returns. The largest black hole humanity has ever confirmed. 66 billion times the mass of our Sun, old enough to have formed when our universe was still a child. And at this very moment, something from TON 618 is traveling toward Earth. Something that has been on its way for more than 10 billion years. Something that, in a very real way, has already arrived. Whether that should worry you is what the rest of this video is going to answer. But not yet. Because to understand what is happening right now between that ancient monster and this planet, you first need to understand what TON 618 actually is. Before we go further, we need to clear up what a black hole actually is, because the picture most people carry around in their heads is wrong. Black holes do not reach across space and pull things in. They are not cosmic vacuum cleaners. If you replaced our Sun with a black hole of the exact same mass right now, Earth's orbit would not change. The planets would keep spinning in their lanes. We would all freeze to death in the dark, yes, but gravitationally speaking, nothing would move. A black hole is just a region where enormous mass has been packed into a tiny space. Get too close to the center, and the pull becomes so strong that even light can no longer climb back out. The edge where light loses that fight is called the event horizon. Think of it less as a wall and more as a one-way door. Cross it, and the universe behind you stops existing as a future you can ever return to. Most black holes fall into two groups. Stellar mass black holes form when a massive star collapses at the end of its life. They weigh somewhere between a few and a few dozen times the mass of our Sun. Supermassive black holes sit at the centers of galaxies. Our own Milky Way has one, called Sagittarius A star. It weighs about 4 million solar masses. For a long time, this was near the upper end of what we expected to find. Big, but comprehensible. Then came TON 618. The object was first noted on photographic plates in 1957, during a survey at the Tonantzintla Observatory in Mexico. That's where the strange name comes from. TON for Tonantzintla. 618 because it was the 618th entry on the list. Nobody thought much of it at the time. It looked like a faint blue star, one of thousands. It took another 15 years to realize the object had been misidentified completely. By the early 1970s, improved spectrographs revealed that this faint blue star was not a star at all. It was a quasar. That word is short for quasi-stellar object, and it describes the active, feeding core of a very distant galaxy. The light we were seeing wasn't coming from a sun. It was coming from a galaxy's central black hole, surrounded by a swirling disk of doomed matter so hot and so bright that it outshone every star in the galaxy around it. That was strange. But quasars by themselves were nothing new. What made TON 618 different came later, when astronomers measured its redshift. The light had been stretched so dramatically by the expansion of the universe that they could calculate how far it had traveled. The answer was a little over 10 billion light-years, meaning the light reaching us had left its source when the universe itself was less than 4 billion years old. An infant cosmos by today's standards. And the object producing that light was, by every measurement we could make, utterly unreasonable. Here are the numbers, because this is where TON 618 stops being interesting and starts being frightening. Our Sun, by human standards, is enormous. You could fit about 1.3 million Earths inside it. Compared to most stars in the galaxy, our Sun is average. Compared to the biggest stars in the Milky Way, our Sun is actually on the small side. Fine, scale is relative. Now take our Sun and imagine 66 billion of them. Some recent revisions put the figure closer to 40 billion, which honestly doesn't change the picture. Either number places TON 618 in a category of its own. There is no common word for a black hole this heavy. Astronomers had to invent one. They call it ultramassive. Every star you have ever seen in the night sky, every constellation, the entire river of the Milky Way across the summer horizon, all of that mass poured into one point, and it still would not be enough. That object's event horizon has a radius of roughly 1,300 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, about 93 million miles. Pluto, the farthest major body in our solar system, orbits at about 40 astronomical units. That means the event horizon of TON 618 reaches more than 30 times past Pluto in every direction, and from edge to edge through the middle, it spans roughly 2,600 astronomical units. You could line up dozens of full solar systems across that span, Sun to Pluto to Sun to Pluto, and still have room left over. Light itself, the fastest thing in the universe, would take about 2 weeks just to travel from one side to the other. 2 weeks for a beam of light to cross a single hole in space. If you could somehow hover near the edge of that event horizon, which you could not because you would be dead long before you got close, you would see the universe bent into a single point. Space itself would warp so severely that the stars behind you would appear in front of you, distorted into rings of light. Your watch would tick slower than a watch on Earth. Drift a little closer, and a minute of your time would be a century for everyone you left behind. The sky you would see from that vantage point would not look like a sky at all. It would look like a lens. Every galaxy in the observable universe would be smeared into a thin, bright halo above you, while below you, where the black hole waits, there would be nothing. No light, no texture, just a perfect circle of absence, so complete that your brain would refuse to process it as a surface or a shape. Just the bottom of everything. And that's just its geometry. We haven't even talked about what it's doing. TON 618 is not a quiet black hole. It is a quasar, meaning it is actively feeding. A constant stream of gas, dust, and whole stars is spiraling inward, heated by friction to temperatures of millions of degrees before vanishing across the event horizon. That superheated disk of doomed matter is what shines so brightly. The disk around a black hole this large would extend for light weeks in every direction. Stars that wandered too close would not fall in as solid objects. They would be torn apart by tidal forces long before reaching the horizon. Stretched into thin streamers of gas, spun into the disk, heated until they glowed, and then pulled under. We have seen this happen on smaller scales, around smaller black holes. We call those events tidal disruptions. At the scale of TON 618, entire star clusters could be devoured over the course of a human lifetime, and the quasar would barely register the meal. The luminosity of TON 618 is estimated at about 140 trillion times the brightness of our Sun. 140 trillion. If you took the entire Milky Way galaxy, every single one of its roughly 400 billion stars, and placed that galaxy right next to TON 618, the quasar would outshine the galaxy by a factor of several thousand. One object brighter than thousands of galaxies combined. That is the light currently registering in our telescopes. And that is how we found TON 618 in the first place. The glow, the impossible luminosity. It is how we measured it, how we classified it, how we know it exists at all. But the light is only a symptom. It is the visible effect of something much larger underneath. And once you do the math on that underneath, the numbers turn impossible. And this is the part that keeps astrophysicists awake. A black hole with 66 billion solar masses should not have existed only 4 billion years after the Big Bang. Black holes grow in two ways. They eat matter and they merge with other black holes. Both processes take time. A stellar mass black hole that feeds as fast as physics allows, a rate known as the Eddington limit, still doubles in mass only every few tens of millions of years. Run the math, and you cannot grow a 66 billion solar mass black hole starting from a single collapsed star in the span of a few billion years. There is not enough time in the early universe to build something that size by conventional means. So how did Ton 618 get so big, so fast? Astronomers have three main ideas, and none of them are comfortable. The first is called direct collapse. In this scenario, giant clouds of primordial gas in the early universe skipped the normal star formation process entirely and collapsed straight into black holes of perhaps 100,000 solar masses each. Starting with a seed that large gives you a huge head start. Grow from there, and you can reach billions of solar masses in the time available. The second idea is runaway mergers. In the crowded cores of the earliest galaxies, massive stars collided, formed black holes, and those black holes merged with each other in rapid succession. Each merger kicked the growing monster up to a higher weight class. Repeat the cycle fast enough, and you end up with something like Ton 618. The third idea, which some researchers have started to take more seriously, is that primordial black holes formed in the chaos of the first fractions of a second after the Big Bang. If they existed, they would be direct products of density fluctuations in the earliest universe, and they could have started growing before the first stars even lit up. In that version of the story, Ton 618 was never a thing that became a black hole. It was born one in the first moments of the universe itself, and it has been feeding ever since. We do not know which answer is right. We may never know. Every model currently on the table forces us to admit something uncomfortable. The early universe was building things that, by our rules, should have taken much longer to build. TON 618 is the hard evidence. And now we come back to the question we started with, the one that is probably still sitting in the back of your mind. Is TON 618 actually heading toward us? The answer has two parts. The first part is that the object itself is not. The expansion of the universe is carrying Ton 618 away from us, faster every year. As you are watching this, the physical distance between Earth and that black hole is growing. In the most literal, measurable sense, TON 618 is retreating into the dark. The second part is harder, because nobody has ever actually seen the object. Nobody ever will. What we see when we point a telescope at that patch of sky is light, very old light. The photons reaching our telescopes tonight left TON 618 when the universe itself was less than 4 billion years old. Earth did not exist. The sun did not exist. There was no rock, no ocean, no atom in your body arranged into anything you would recognize. The light began its journey anyway. 10.5 billion years through expanding space, through galaxies and voids, aimed at a patch of emptiness where, one day, a planet full of curious primates would aim a telescope back. Most of those photons were lost along the way. A tiny fraction survived. They are arriving right now. They will keep arriving for as long as anyone on Earth keeps looking up. So yes, something from Ton 618 is heading toward us. It has been heading toward us for 10 billion years. It is, at this exact moment, tonight, hitting mirrors on mountaintops all over this planet. The object itself is fleeing into the expansion of the universe. Its light is still finding us. And every photon that completes the trip carries the same unsettling message. The universe's biggest monsters existed earlier than they should have, grew faster than they could have. And none of the available theories closes that gap cleanly. There is one more thing worth sitting with. Ton 618 was not discovered because somebody went hunting for a monster. It was noticed almost by accident on a photographic plate from the 1950s. And only decades later did anyone realize what it was. Which raises an obvious question. How many more are out there? Surveys in the last few years have been uncovering other ultramassive black holes. Some of them are almost as big as Ton 618. A few might be bigger, though measurements at these distances and scales come with enormous error bars. The James Webb Space Telescope, since it began operations, has been finding supermassive black holes in galaxies so young that their very existence is, once again, theoretically inconvenient. Webb has spotted objects it was not supposed to find, shining in the distance at ages when the universe had only just begun assembling its first real structures. Little red dots, astronomers are calling them. Some turn out to be active supermassive black holes, already grown to millions or billions of solar masses, in a cosmos only a few 100 million years old. The deeper we look, the more monsters turn up. And the more monsters we find, the clearer it becomes that the early universe was not the slow, patient builder we assumed it was. TON 618 is not unique. It is simply the biggest one we have confirmed so far. That record will almost certainly fall. Somewhere out in the archives of the sky, a larger one is probably already sitting on a photographic plate, waiting for the right astronomer to notice. So what do we do with something like TON 618? We cannot visit it. Even if we invented a spacecraft that could travel at the speed of light, a one-way trip would take more than 10 billion years. We cannot send a probe. We cannot study it up close. All we will ever have are its photons, arriving tired and stretched and ancient, carrying a story we are still learning to read. But the photons are enough to shake the foundations of what we thought we knew. Every textbook model of black hole growth, every timeline of galactic evolution, every assumption about how mass accumulates in the young universe has to make room for Ton 618. The object is a test case our theories keep failing. And perhaps the most humbling piece is this. If you stood outside our galaxy and looked back toward home, the Milky Way would appear enormous. Hundreds of billions of stars, arms of gas and dust curling across 100,000 light years. Every civilization we know of, every war, every love story, every name ever spoken, all of it contained in one faint spiral of light. TON 618, sitting at the center of its distant host galaxy, outweighs our entire Milky Way by itself. Not the galaxy, the stars inside it. All of them, combined, compressed into a single point, and the light from that single point is what lands in our telescopes tonight. We are not in danger from TON 618. The math on that is clean. It is too far away to affect us gravitationally, and the expansion of the universe guarantees we will never grow any closer. But danger is not the only way a thing can be frightening. TON 618 is frightening because it reminds us that we do not live in a universe we understand. The rules we wrote down to describe how mass and gravity and time interact work beautifully in the neighborhood around our sun. They hold up for stars like ours and galaxies like ours, and black holes at the scales we have mapped. Out there, at the edges of what we can see, though, the rules start to look like rough drafts. The universe was doing things in its infancy that our equations still cannot account for. Every night, as TON 618's ancient light crosses the last few miles of its 10 billion-year trip and enters the mirror of some telescope on some lonely mountaintop, a message keeps arriving. A message from a time before the Earth, before the Sun, before anything you have ever called home. The message is short. It says, "You do not know how big things can get. You do not know how fast they can grow. You do not know how much of the universe is still hidden from you." And somewhere in the darkness between galaxies, the sender is still out there, still feeding, still growing, still sending. We are looking at a ghost that hasn't finished writing its story. The next telescope image of TON 618 will capture light slightly newer than the light we have now. Only by a few seconds, but it will be newer, closer to the present. Every moment we study it, we pull a thread, and the thread keeps getting longer. Whatever waits at the other end, in the real present of the universe, is something no human will ever see. But it is there. It is still there. And in the deepest sense of the word, it is the scariest object humanity has ever found. Thanks for watching, and I'll see you in the next one.